Yeah.
package to start from
Yeah.
there. Okay.
Sure. Sure. Sure.
Okay.
See, let me bring that slide first. Yeah. So these are all packages that, right? So what package means is, if you have already, there might be a nice Java project, right? Or there might be a nice Java library which is open source, and you can download that and you can use it, right? So in that sense, what you need to do is, you don't need to worry about how they have coded. Only thing you need to worry about is how, what should be your input, and what should be your input format, whether you are specifying your input format or not, and the output would be given, right? So everything, let's say, for example, for a very small example, let's say, uh, area, okay, area of a shape. So to calculate area of a shape, you have to write whether it's a circle or not. If it is a circle, its formula is different. If it is a square, its formula is different. If it is rectangle, it is different. If it is triangle, it is different. If it is something, some other trapezium, it is different, right? So those kind of things. So in that sense, you need to worry about a lot of stuff. But instead of that, what I'll do is, I'll write the code for you, and I'll give it to you as a package where you just have to tell me what is the shape. Okay, if you say, okay, circle is my shape, and then you have to give me parameters, like, so if circle is the shape, then let's say there will be two parameters given. One is height, and height and width, right? So in rectangle and triangle, rectangle, triangle, or square, height and width are sufficient. But if it is circle, only one parameter is required. So in that case, what will happen is, for example, let me just uh, so what I'll say is, area, I'll just call a function area. I'll say shape is circle, right? And I give, let's say, 5. So here 5 will be my radius, right? So my area function would be something like this. My area function would be like, shape, length, and breadth, right? And the breadth will be optional, because if the shape is circle, you just need one parameter, right, to calculate the area of the circle. If it is a triangle, rectangular, square, you may need length and breadth, right? So if it is square, you just need one again. So like that. So what I'll do is, I am going to write all the codes for you, and I'll basically, what I'll do is, I'll package my code and I'll give it to you as a library. Okay, I'll give it to you as a library. You just use that library, you just call that library inside your own code, and you don't need to write the area formula again. You just call this function. Okay, so that is why the package are for. So instead of doing everything from scratch, because R is an open source community, what people are doing is, they are writing their, whenever somebody develops something unique, okay, something valuable, they package those things and they distribute over the internet, and they actually upload to the cran site, and in the cran site you can get that as a package, and you can help yourself, right? If you want to do the same thing, instead of writing the code from the scratch, just use that package and solve your purpose. Did I answer your question?
Yeah. See, how will differentiate that
Your voice is
appropriate packages? We have to go through or know that what
Yeah, Anand, your voice is breaking. Pranav, did
we
you, are you able to hear properly?
will depart you are. I'm studying today. Lot of packages which can get to set there, and lot of packages which are already in the
Okay, how do you differentiate between each of the package? See, each of the package are for different thing. For example, um, if you look at here, forecast. Okay, forecast is a package to do actually forecasting, like stock market forecasting, or how much rainfall will happen tomorrow. So all those kind of forecasting. Okay, forecasting will be done by this forecast package. Whereas SQLDF is a package where actually you can write SQL type queries. Okay, instead of writing any code, you can, the way you do query into the database, you can do similar kind of you can use similar kind of language and actually query into the data set. Okay, for example, string r is a very nice package for doing any string manipulation. Okay, doing any string manipulation, it can extract a, for given a paragraph, it can extract and give you whatever you want. Okay, you can write some regular expression, you can join two string, you can separate all the words, you can count the words, you can replace some portion of a sentence with some other text. So all those things. Reshape is like uh, converting the data format into one to other. Let's say you have so like length and breadth. So if your data is like this, okay, and let's say you want to transpose, let's say you have 4 rows and 10 columns. Okay, and you want the data into some other shapes. Okay, probably you want to say, okay, you want to divide one of the column into multiple variables. Let's say the 10th column, instead of the 10th column you want another 4 columns instead of the last column. So those kind of things can be done in reshape. ggplot, again, it's a very good package in drawing some nice beautiful plots. Okay, so similarly, so each and every package will have a description on the top of it, that what is the package is all about. It's not, it will never happen that you will get confused whether you should be using this package or this package. There might be few packages which will do the same task, but not all the packages will do all the tasks. Anand, did I answer your query? Okay, fine. Okay, then let's begin for today. And okay, so we had some issue last time, if you remember. Uh, I need to first clarify that before I begin for this course. And don't worry, all the packages I'll be introducing to you when time comes, because when we have started learning R, how to start coding in R, in that phase only, phase by phase, I'm going to introduce all these packages. It's all the packages will be introduced to you. Okay, because you need to understand what's all these codes are doing, right? So unless you know little bit about R, you will not be able to actually understand and not be able to appreciate the effort in the package that people have given. Okay, so one thing, if you remember, uh, this is if you remember, we had okay, let me start my R Studio again. Do not save. I'm starting my R Studio again. I prefer to start as an admin. Okay, my R Studio. Always start as admin. If you have admin access, always start as admin. Now, let's see this. Here, so this is my command prompt. You can execute some so script here. You can even write code here. This is your file where you can write code. You write your script and execute here. And this is, if you remember, this is here where your plots will come. In this area, all your plots will come. And on this portion, you will see all the variables and everything that you have initialized, right? So but we were facing some issue. Okay, first thing what I told you is, if you want to know what is your directory, okay, control L. Whenever you press control L, you can clear your console. Okay, and if you write get wd, okay, get wd is the command. It says get working directory, then you will get what is your working directory. So right now my working directory is my documents only, right? Documents is in Windows 7 is nothing but my documents. So by default you will be taken in this place, okay, and this default directory, this is a default directory, and this default directory is actually is also represented by a symbol called tilde. Let me show you it. This default directory is also represented by a symbol called tilde. Okay, so if I now bring my slides here, it says, right, set working directory. It has given tilde. Tilde means my default directory slash my directory. What it has done is from the working directory, it is going to another subdirectory, right? So that means this my directory should be inside my documents, right? So so that is why the problem was right now. This is my this is my document, right? That is where I am pointing to. Now let's say I create a folder here called, let's say, test. Okay, let me create a folder called test. Now if you want to go to, if you want to create, I mean set your working directory as the folder inside the document, that is test folder, instead of the raw directory or default directory. If you want to set the test as a your working directory, so what you need to do, either you type this one, set working directory. Okay, let me erase this. Hold on a second, guys. Okay, so here, if you want to, if I want to set the directory to the test folder, either two choices. Either I'll give my full path. So here I'll, if I want to give my full path, I can give c colon users colon the name of the user, then documents, then slash test folder, right? So this will take me to that particular folder, but instead of that, because I'm already in this folder, I just want to go inside this, right? From this directory, I just need to go to the test folder. So instead of writing all this, I am going to represent it by a symbol called tilde. Okay, so that will take me to the folder. Now look at the working directory. Get wd is nothing but the test. Okay, so that is what. But let's say if you are let's say I set my working directory to, this is a common mistake you may do, so be careful. If you set your working directory as, let's say, uh, D drive, and let's say training. Okay, let me check if I have a folder called training, D drive and training. Okay, so I have a folder called training. So training, cannot change set working directory training. Okay, oh, let me check. Oh, it's F drive. Sorry, it's not D drive, it's F drive. Okay, now get working directory is my here. So now let's say inside this you want to go to demo class. Okay, let's say, or let's say practice. You want to go here, but if you want to go to the practice folder, you cannot use something like this. Set working directory, and inside this uh, tilde slash practice. I cannot say it like this because tilde means your default directory. Whenever you start your R Studio, the default directory it arrives, that is being represented by a short form tilde. Okay, so tilde doesn't mean at which directory you are writing. It doesn't mean that. Okay, so if you do that, it will say cannot change the directory. So but let's say you want to go to practice, okay, practice folder. Instead of writing the whole path, what you need to do is just put a dot. Dot means wherever you are right now, and it will take you there. Okay, now say get working directory, it gives you the full path of that particular thing. Okay, is it clear? Just ping me if it is yes or no. We'll start for the next session. And Anand, I'll solve your problem about the videos. Don't worry about that. After the class, I'll solve your problem. Okay, so yesterday, last time we just had a look at how our studio looks like and where I can write script, where I can execute, and where I can plot graph. But we have really not begun what is inside R, how you should start doing, how you should practice R, or how do you know what are the data types at all. So today, from today onwards till next 5 classes, we'll be learning thoroughly R. Like as far as possible, we'll learn it thoroughly. Okay, so let's begin. So let's look at first the basic operation that I can do. Okay. Um, So what are the basic operators? So today's agenda will look at basic operators, and we'll look at some built-in functions. When I say some built-in functions, when I say some built-in functions, it will be the built-in function without adding any extra package. Okay. Right now, I have not added any other package that were shown in that last PPT. In the last PPT, right, we are showing a lot of packages. I have not added anything out of that. So whatever are the default packages installed by R during the installation process, using those only, uh, I mean, inside those default packages, we'll look into some major functions which will be for your use on a day-to-day life. Okay, whenever you will be coding in R. So that is a built-in function I am talking about. Then we'll look at what are the data structures, like what are the kind of data types and data structures are in R. So we will also look at vectors. So first is like we'll just discuss how many data types are there. Then out of the data types, there are two data types we'll be covering in detail, and we will try to do some operations over those data types. Okay, so let's begin. So operators. Operators means first look at what is the assignment operator. So the assignment operator is very simple. In any language, if you have ever done something, what do you write? Let's say there is a variable called x. Okay, let's say there is a variable called x, and x is a scalar. Okay, I say x is a scalar. Scalar means it can contain only one value. Okay, guys, if I am not able, I'm not looking at your chart and responding you in time, just unmute yourself and just stop me. Okay. Uh, so, let's say x is a scalar. So that means x can contain only a single value. Okay, that's what the scalar means. So if x, I want to assign a value of x equal to, let's say 10, right? So normally, how do I assign x equal to 10? Like this. Okay, in R also you can do the same thing. You can use x equal to symbol, you can use equal to symbol to assign something. Okay, you can use this symbol to assign something. Apart from equals, there are two more way you can assign is like this. You can use an arrow. So first I was using like x equal to 10, right? So instead of that, I can also write like this: x is assigned a value of 10. Okay, I can also write, we'll try this. This should also work. 10 is assigned to x. Okay, but when you are using x, right, when you are using x equal to 10, when you are using this equal symbols, your variable should be on the left side and the value that you are assigning should be always in the right side. But there is a freedom when you are using an arrow symbol. You just based upon your arrow thing, like the arrow should be pointing towards the variable or your scalar. For the time being, it's we are using scalar, and the arrow, the pointer should be directing towards the scalar, and the value should be on the opposite direction. That's it. So let's try this simple thing. Okay, see this, x equals to 10. Done. So my x variable is 10. X is also assigned to 10. This you also can write. And 10 is, let me try something other value. You may say that all 10 is already assigned to x. So 12 is assigned to x. This will also work. See, x value is 12. But 10 equal to x will not work because this is invalid statement. So the direction has to be proper. Okay. But using arrow, you have the liberty to write in any way you want. Okay. So next slide. So this is basically assignment operator. Similarly, there will be a lot of other operators, okay, like plus, plus, minus. These are for addition and subtraction. Star is for multiplication. Divide by is for division, okay, and two percentage symbol. Okay, it's not single percentage symbol. Two percentage symbols simultaneously will represent remainder operations. Okay, and this is your power operation, like x to the power 2. If you want to write x square, you can write x to the power 2. Then this is a relational operator. If you want to write greater than equal to x, if you want to check something, x is greater than equal to, or x is smaller than equals to, if x is exactly equal to, if x is not equal to, then these are all the relational operator. We will be taking a lot of examples during our course. Okay, so don't worry about this. Logical operations. Logical operation means not. Okay, anything you want to write, but if you just put exclamation mark in the front, it will say not. Logical operation and two condition you can join by and. I'll show you that. It's something like, if you write, for example, if I write if, okay, there is a way I can write if. In that condition, if x is equal to equal to uh, let's say, not like this, if x is greater than 10 and x is less than 20, because I want to limit my x value between 10 to 20, right? It should be 10 to 19. So if that is the case, then I'll do something. So you can actually use two conditions by a conjunction called AND operation, right? So that is the meaning of the AND means. Tilde is a special where you'll be using for formula when you'll be doing regressions, right? Regressions or logistic regression, we'll be using this formula heavily. Okay, you'll be using this symbol heavily, not now. And we already saw, right, this arrow mark, left side arrow mark or right side arrow mark, you can use as an assignment operator. Dollar, you will see very soon, you will see how I'll be using dollar. Okay, dollar is basically if there is a the table kind of structure. Okay, there is a table kind of structure and I have rows here, right? I have rows here, let's say 1 to 100 rows are there, and let's say I have three column. Okay, let's say A column B, column C, and let's say this table name is, let's say, T. Okay, so if I write T dollar A, it will fetch this column for me. It will gonna fetch this column for me. If I write T dollar B, it will be fetching the column B for me. Okay, similarly T dollar C will fetch the column C. So that is how we'll be using. Okay, and this sequence, full colon, this full colon is for generating a sequence. If you write one colon 10, it will give you values from 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So it will generate a sequence. For example, I just write 1, 2, 10. So it will gonna generate a sequence for me, right? So this is how it will be using a sequence. So this is like you want to generate very fastly. Let's say you want to do you are doing some testing or sampling or something. You can do that, but on the need basis. Okay, be careful that it will be just generating numbers with an incremental value of 1. Okay, you cannot do an increment of 2 on this if you just use a colon operator. Now, go to the next slide. Okay, now look at this. This is a division, right? 14 by 3 is a division, and I'm using a log operation. So this is how you can also do a log operation. So 14 by 3. 14 by 3, generally what happens is any other language, okay? If you write 14 by 3, what they will do is they will 14 by 3, they will just take the complete integer out of it. So 14 by 3 would be somewhere around, how much would be 14 by 3? 14 by 3, right? So 14 by 3 is mine 4.67, right? 4.67. But if I'm going to use in Java or some other language where, because 14 is an integer and 3 is an integer, so it will just return me 4 instead of 4.67, right? But in R, it will treat each and every number as double, like double in the sense fractional value also it will take. So 14 by 3, it will give you 4.67. Okay, it will not truncate the number into a complete integer. Okay, so that is where you don't need to worry about defining it as an integer or double. So R will take it as a double value. Okay, by the way, double means it can take any value. It can take 4.2, it can be 5.7, it can be minus 10.2, any number. Okay, so after decimal value also it will take. So that means it is double. double, double. If it is integer, it has to be number from 1 to n, right? 1 to n. It should be a complete number. Okay, it cannot be anything else. And this is how you can do operations. And one more thing, let's say you want to do so let's say 9 plus 7. What it has done here is 9 plus 7. How much it will give you? 16. In another line, if you have written, let's say 2 star 4, it will give you 8. What you want to do is you don't want to write in, so let's say this is your prompt. If you look at, this is your prompt, right? You have a prompt like this, right? You have a prompt like this. So I'm writing here, if you can see my screen. Yeah. Let me just maximize it. What I'm writing is, let's say 7 plus 9. So it gives me 16. Let's say 3 star 4. Let's say these are the two instructions, 16 and 12, right? Instead of writing in a separate line, I just want to write it in one shot. So what you need to do is 7 plus 9, end it by a colon, semicolon. When you put a semicolon, it understand that, okay, this particular instruction is over. After that, you can give some space and write 3 star sorry 3 star 4 and give a semicolon. So it will understand that you are executing two instructions. So it will give one first value is 16, second value is 12. So this is the way also you can write. Okay, now some built-in function. Let's look at some built-in function. One built-in function, we're already doing it here, log. Okay, now to make you understand, when I just write log function, okay, so let me write, if I write log of x, if I don't mention anything, because it's a logarithmic function, right? Logarithmic function can be log of e, can be log base 2, can be log base 10, can be anything actually. It can be anything. We know these are the common log operations, but it can be anything. But when I'm writing something like this, because I am not giving any base here, right? There is no way I have given base value here. That means it is by default, it is log e operation. By default, log is log e, log base e, so it's log base e operations. Okay. So similarly, we can also have other common built-in functions. These are like log x. Log x is base e. Exponential, if you want to do exponential, e to the power x, right, where e is equal to nothing but 2.1718. There is a typo here, don't worry. 2.718 is your e value. If you see here, 2.718 is your e value. Here we should be putting a point here. Okay, we have forgot to put a point here. So it is exponential. Like now let's say you want to define a log operations and you want to say what should be your base. So in that case, what you can do is you can say log. Inside that you can give a value x, then comma, you have to give the base. Okay, let me show that to you. Say, let's say I just write log is equal to log of, let's say, 10. Okay, when I write log of 10, I know that it's by default it's a log e operation, right? Log base e, so I'll get something like 2.30. But let's say I want to do a log of 2 base 2. In that case, what I'll do is I say log of 10 comma 2, so 2 is for the base. Okay, so 3.21. For example, we know log of 2 base 2 is always 1. Something, log of something based by the same thing is always 1. So log of 2 base 2 is 1. So you can verify that here. Okay, so you can actually, on the second parameter inside this function, you can give the base value. Okay, now there is one more exclusive function. If you want to do a log base 10, you can directly write log 10 of x. See, log of 100, let's say log of 100 base 10 is 2. Okay, it's like 10 to the power 2 is 100. That's it, that's all. So but instead of that, there is this exclusive function for log 10. Just write log 10 of 100. It will also give the same answer, 2. Okay, that is what we're talking about. So square root of x means just same thing, just it's very implicit. It's square root of x. You want to calculate the factorial of a number, factorial, you just write factorial is a function and give pass the value, whichever values factorial you want to calculate. I hope you know ever about factorial, right? It's factorial of 4 means it is 1 into 2 into 3 into 4, and factorial of 0 is always 1. Okay, now let's look at these three things: floor, ceiling, trunk, and round. Okay, floor, ceiling, trunk, and round. Let's watch closely this four function. Let me first explain you what are these function. Then we will try to write their code in the RStudio. Okay, so first let's say x equal to 5.7. Let's say x equal to 5.7. Okay, so of floor function of x will give me the greatest integer, which is just small to this, the complete integer value, which is the highest possible uh, the highest possible integer which is less than 5.7. Can you tell me what is the highest possible integer which is less than 5.7? Please answer me. Which is the highest possible integer less than 5.7? Okay, cool, 5. Correct. So that means your floor will be 5, right? So your floor will be 5. And what will be my ceiling? Ceiling, ceiling function. Ceiling function of x is the lowest possible integer which is greater than 5.7 or greater than x. So what will be the value? 6, right? 6 is the lowest possible value which is greater than this one. Okay, so it will be 6. Now trunk, trunc. Okay, although it says another function, but it is was same out of one of these two. Let's see what is it. So closest integer to x between x and 0. So what is saying? Closest integer to x between x and 0. That means it is same as floor. Okay, it will be same as floor. So it will all see trunk function is nothing but the floor function. Let's try that. Okay, these three functions. Before we do anything else, let's try this. So my x equal to 5.7. Let's say floor of x is 5, trunk of x equal to also 5, and ceiling of x equal to 6, right? Let me change the function x equal to let's say 5.3. Let's check everything. Say 6 as per our understanding. As per our understanding, floor will be 5. Yeah, I have a question here. Why the trunk is there if it executes the same? I mean, there are. I need to check 1 second. Let me just finish it. I'll check that whether they belong to the same package or not. Just hold on a second. Trunc of x still 5. Let me check that for you. See, let me first say help. I want to first check floor, which package it belongs to. Floor is for the base package. Okay, so ceiling takes the single numeric argument of x and returns the numeric vector containing the smallest integer not less than the corresponding element of x. Ceiling, floor. Let's look at floor takes a single numeric argument x and returns the numeric vector containing the largest integer but not greater than corresponding to the element of x. Okay, now trunk takes a single numeric argument and returns a numeric vector containing the integer formed by truncating the value in x towards 0. Okay, truncating the value of x towards 0. Give me a second. It says truncating the values in x towards 0. If it is x equal to 5.9996, let me check. TRUNC of x, is it 6? 5. I I think it is trying to the way it is trying to, it is actually calculating the floor or trunk is separate, is different. Here in floor, yeah, I have a question. Reverse. What is reverse? Anand, can you tell me what reverse means? What do you mean by reverse? It's not taking the value from the reverse. Yeah, but the way what I'm saying is the way it is calculating the floor is different. Here, what it does is anything that you calculate. If I write 5.4, right? If I write, okay, let me write something about that. If I write 5.46 in floor, it just check the numeric part of it. Okay, it just check the numeric part of it. What it will do is anything between 0 to 5. I mean anything between 0 till this number, but it's a complete number, so it gets 5. But in trunk, it try to cut numbers from, it cuts number like this. It will first take this out, and till it takes out all those decimal place. So it will take out all the decimal place, and whatever it is left, it will say, okay, I have truncated all the decimal place. So the meaning of trunk is it will it will cut out all the decimal places, and it will give you whatever is left to the left of the decimal. That's a complete number. But ultimately, floor and trunk will give you the same value always. Okay, if you find it is different anytime, please approach me. But as far as I believe, it will be giving you the same value every time. Okay, let's proceed. Okay, that's a tricky question actually. It's not very easy to answer, but good that you asked. Now let's look at something called round. Okay, now the round is important. Okay, round is very important, and the round function is, let's say x is equal to 5.746. Let's say round x is equal to 5.746. I want to round it off the way we say, right, in our when we play with numbers or when we play with, I want to just round it off to the nearest number. You say it will be 6, right? So that's what your round function will do. What you need to write is round of x, and you say digits equal to 0. Okay, when you say digits equal to 0, it will round it off till this. So it will try to round off the whole thing. And what it will do is, first it will look at um, 6, right? So 6, if it rounds up 6, it's more than 5, right? So it will make this 5.746 will become 5.75, right? Then 5.75 will become 5.7 or 5.8, depends upon what kind of algorithm they have developed. So because 5, it can go in either way. Now 5.7, because it's digit 0, right? So it will nothing on the decimal side, so no numbers after the decimal point. So when it round it off, it's more than 5, so it will become 1, and 5 plus 1 becomes 6. So you get a number called 6. If I would have just given digit equal to 2, if I have given digit equal to 2, I would have received a number called 5.75, right? Because it will round up till 2 digits decimal places after the decimal point, right? So this is how it will gonna work. Now, signif, it's a like scientific notation. So let's just see that. Signif is also pretty similar. Uh, let me just execute that for you. Signif, say x equal to 5.67, and say SIG in signif. What I'm doing, digit equal to 6. So x comma digits equal to 6, 5.67. It is, and let's say, let me just mention something called x equal to 67. So I've given a number, bigger number, okay? After decimal, I have lots of like 11 or 12 numbers. Then I'll just write in signif, and I just say x. So signif x means it will give me only 5 number after decimal. So by default, what it does is total number of digits will be displayed as 6. Okay, that's the default format of a signif functions. And if you are mentioning minus, let's say if I'm mentioning minus equal to, let's say minus 5, let's say minus 5.6789, let's say 346. Okay, so I have more than 6 digits, right? Including minus, there is another sign called minus. If I do that, signif of x, so by default value is 6, okay, in signif functions, and by default digits value is 0 in round functions, right? So that means it will try to give you 5 decimal points after your x value. So now let's see, when it is a minus, is it giving 5 decimal places after the decimal point, or it is giving me 4? It is still giving you 5, right? So basically it is nothing to do with sign operations. It will just show you the sign, and irrespective of the positive or negative number, it will gonna show you maximum 5 digits number. Okay. um, so sorry, maximum total six numbers. Okay, including before decimal and including after decimals. Okay. uh, Now let me try one more thing. 1, 4, 5, 6, 7, 8, 9, 10. So this is just a pure number. And let me see what is sine function is doing in this case. Is it truncating or it's not truncating? Okay, and I need to assign it. Let me assign x equal to this number. So if you see, I have assigned a bigger number, right, which is more than 6 digits without any decimal place to x. I'm running sine function of x. Do you see what it is doing? It has taken 6 digits. Okay, 1, 2, 3. So 1, 4, 5 is 3, 6, 7, 8. So till this 1, 4, 5, 6, 7, 8. Sorry, 1, 4, 5, 6, 7, 8. It has taken because the maximum default length is 6, and after that it has just put zeros. Okay, so it will not consider, because if you want to. So that's how the scientific numbers, because when you do scientific studies and all, right, they really don't take the full number. Instead of that, they take the nearest number having zeros, because it's easy for them to do scientific computations. So if, let's say, I want to do something like, yes, somebody has a question.
Yeah. See, you have taken 1 4 6 7 8 9 9, and it have given 1 4 5 6 7 9. So
Yeah.
is it taking?
Why is 9? Because it is rounding off, right? It is rounding off. 9 is being 999. If you round it off, this 8 will become the 9, right? And this will become 000, because it will round off, and it will only consider numbers till first 6 digits. So
Okay.
8999, you want to round it off. So it will become
Okay.
9000, right? That's how. So
Yeah.
let's do another operations here. Sign in or sign if of x, comma, digits equal to, let's say, 5. If it is 5, what it should be? See, 8 has 8. If 8 is becoming 9, because 999, right? So anyway, 9 is here. So it will, if you round it off, it will become 9. If you round off 9 also, this 9 also, this will become 8, right? So I should be getting 1, 4, 5, 6, 8, then 4 zeros. I got 1, 4, 5, 6, 8, and 4 zeros. That's how the scientific calculations. Okay, it's up to you. I mean, you may not want to do it, but generally when people do scientific studies with numbers and all, they try these things, because they don't want to. Because if you do a multiplication with the original number with something else, it will be very difficult, right? Whereas if there are lots of zeros towards the end, doing a multiplication is very easy. That's one of the biggest reason why uh, we use this kind of functionality in scientific computations. Now let's yes, some question.
Irrelevant question. Will it
No problem.
be all these things will be needed while doing this business analytics, this mathematical calculation and all?
Yeah, yeah. I mean, let's say you want to, let's say you want to do something on your annual sales. Okay, let's say you want to do some quarterly annual sales projection or something. Okay, there
Okay.
quarterly annual sales projection, you got some raw numbers, and this is in terms of billions, but it has continued till the last digit. But when you are talking about billions, would you be interested in the thousands and all,
Okay.
right? If I have a number like this, if I have a number like billion, right? So let's say 2, 3, 9, and let's say billion. Let me say 6, 7, 0, 0, 8, 4. How many numbers? 1, 2, 3, 4. Let's say this is my figure. Okay, and this is my figure, and I always know my company does well, and my company is always in this figure. My company is always having 1, 2, 3, 4, 5, 6, 7, 8, and my company has always 8 digits after the first digit. So in the next quarter might be something 3, 1, 9, 2, 7, 6, something like this. Okay, so always I have a 9 digit number. Always I have a 9 digit number. It's a sale, let's say, or Would you be interested in looking at the full number, or you just first four number would be sufficient for you, or maybe first three numbers, right? So
Okay.
2.93 into, let's say, million, let's say 2.53 million. Just giving an example, it's not million. Million is 10 lakhs is 1 million, right? 10 to the power 6 is 1 million. So this is 1 million, right? Yeah. So 2.39 billion. This is billion. 2.39 billion. 3.12 billion, right? So this is where you will be interested, right? So in that case, what you will do is you will just run a scientific function, and you will truncate this out, and this will become 2.40 billion instead of 2.939, all the stuff. It will become 2.40 billion, and this will become 3.13 billion. If you look at closely, there is a number called 7, so it becomes 3.13 billion. So that's how I would be interested, right? So it depends upon your choice whether you want to run it or not, but definitely you may require it. Okay, it's again up to you. If you want to treat all these numbers, go ahead, do it. But if you're just interested in the billion figure, you can do like this, right? Okay, so this is about clear function. Similarly, so okay, this is sine function. Then you'll have a some random number generation. So this is called, don't read it run unif. So don't read it run if. Okay, read it R for random, and UNIF is for uniform distribution. So this is random uniform distribution. Okay, basically it will create random numbers where the numbers follow a distribution, this distribution. This is called uniform distribution. We'll be talking about all the different form of distribution in following classes, not now but later on when we'll switch to statistics part. We'll be discussing about what are all distribution, but this is one way of generating random number using a function called run unif. Okay, that means generate some random numbers using uniform distribution. And if I give n, what it will do is, it is saying numbers create n numbers between 0 to 1, using uniform distribution. Okay, don't worry about this first, because we'll be doing all this later. Okay, let's not talk about more, or don't think. But similarly, if you know, there is something called normal distribution. If you have heard of Six Sigma, all those stuff, there is something called normal distribution. Okay, if you want to create random variables, random numbers using normal distribution, there is similar function to this. R for random numbers, and for normal, NORM. Okay, pass the value n. So that means it says create n numbers between 0 to 1 which follows normal distribution. Okay, that's all it means. Okay, so we'll not talk more than this. Just understand this is creating random numbers using a distribution. Okay, that's all. This cos x, sin x, all these are trigonometric functions. I don't think it will be very relevant for our classes, but just for those for your information, you should be knowing. You should also be able to calculate the cosine function or tan function, right? Tan cos function, sine function, all these function can also be calculated. Absolute of x, ABS is pretty straightforward, right? Absolute of x is gives you the positive value. It gives you the mod of this. If it is x is positive, it will give you again positive. If x is negative, it will just give you the positive value out of it. So minus 5.7 ABS will be 5.7, right? Because it just gives you the positive number out of it. It ignores the sign, that's all, and it makes the number positive. Okay, this is all about some functions. It's not the complete exhaustive list of all the functions, but some function to start with. And don't worry, go and do practice on those functions. Okay, it's very simple. Just define a number and start practicing on it. So you'll realize what all each of the function does. Okay, let's proceed. Running short of time. Okay, now let's look at some built-in fun. Okay, so now one more thing here. If you want to, so there one way is scientific function, right? We saw in scientific using scientific function, we can truncate the numbers and make it into zeros and all, right? And there is another way also to represent if the number is very big or small. You can represent it by 1.9 into e to the power 3. Let's say what it has done is I have to use, I have to scribble a lot here. Okay, 1900. Okay, let's say not 1900. It's not. It's a bad example. Let's take 19 million. Okay, so mine is it's 19 million. I have written like this. After 19, 5 zeros. Okay, what would you do in this case? Would you always write like this because this is time consuming, right? So instead of that, in R, what we can do is we can say it's 19. After 19 there are seven zeros, right? After 19 there are six zeros, basically six zeros, right? What I'll do is I can write 1.9 into e to the power 7, sorry, e7, 1.9 e7. This means nothing. 1.9 into 10 to the power 7, which is nothing but this number. You can, if you want, you can also write 19 e6 is also same thing, right? 19 into 10 to the power 6. Okay, so basically it's exponential form. Like instead of writing the full number, you can write it in exponential manner. Similarly, it also works for very small number, very small decimal number, something like 0.00034. Instead of that, what I can do is I can say 3.4 into 10 to the power minus 4. If you look at, if you make it 3.4, you have to shift four numbers. So 10 to the power minus 4, this is nothing but 3.4. You can write like this in R, 10 to the power minus 4. Just try this. If you are confused, you can try this also here. Let's say 3.4 e minus 4. See, this is the number. So you can write in this way. If you want, you can write in this way. You can also write the number in this way. Okay. Yeah. If you remember, I was talking about 2%. 2% symbol is remainder, right? So look at this. 52% 2 is like, what is the remainder? 50 by 2, if you divide, it will be complete division, right? Because the answer will be 25 and there will be no remainder. So the remainder is 0, right? Let's say you want to do something. Okay, these numbers are trivial, but let me give you a better example. You want to say in 51, if I divide by 2, how many complete numbers I'll get? Okay, if I divide by 2, what is the integer part? In that case, you cannot do 50 by 2, 51 by 2, because 51 by 2 will give you 25 by 5, 25.5, because that is how R works. R doesn't take anything as integer by default. By default, it will take both as double and it will return you 25.5, whereas any other language would have been given you 25. Okay, so to get the integer part only, what you need to do is instead of 51 divided by 2, you just write 51 percentage divide again percentage 2. It will return you 25. Okay. Um, I mean here 50, this anyway you write, it should give you 25, right? If I write 50 by 2 also, it will give me 25. 50 percentage divided percentage 2 also give 25. But better example is this. You do it, try it with 51, you will know the difference. Okay. And if you want to know the remainder, if you divide by divide 51 by 2, then what you need to do is 50 percentage, just write percentage, okay, not a single percent, 2 percentage, 2, it will give you as 1. Okay, so that is all about this. Let me just run that for you again. 50 percentage, sorry, 51 percentage 2 is 1. 51 divided by 2, it is division. Okay, but 51 percentage divide percentage 2, it will give you how what is the integer part of it. So it's 25. Okay, you want to know this, if you want to know what's the integer part, if I divide two numbers, you have to write like this. Instead of divide by operation, you have to write percentage divided by percentage. Okay. Okay, now let's move to the next one. Okay, now rounding off, I think I have already cleared this, right? Floor operation, ceiling operation, rounding up. So this is already covered. Okay. Uh, yeah, floor operations. Now let's look at. Okay, so we have all in all discussed about few data structures. Now let's look at something in we have discussed about functions. Let's look at some data structures. Okay. If you remember, I have already given you one data structure, which is scalar. Okay, scalar means it contains only a single number. It can be a single number, it can be a string, anything. Okay, let's talk about that. So here we are missing one thing. Apart from all this, I'd also say, okay, A, B, C, D I have already given. Let me just put it as 0. Begin with this scalar. Scalar is just a small one box. If they have represented it as box, let's say just one box. Inside box, you can only keep one value. Let's say x is a scalar. X can be 5. X can be 5.2. You can put a decimal number also. X can be something like, let's say, Anand. I write Anand string, right? I can write a name also in this Anand. So I can write Anand. I can also write something like x equal to x is assigned to true, or on the opposite, you can also write true or false also. You can write false also. This is like binary value, right? False, true, false. So this is also binary value. Okay, so you can write true or false. So these are all kind of assignments you can do. Okay, these are all logical values, true or false. So this is all scalar operations, right? Scalar operation, which we have seen. Like I just told you how to assign a string value, how to represent, how to assign a logical value. But we have almost covered this, right? Now, is let's say you want if you want some kind of data structure where you want to store a series of number. You want to store a series of number. Let me delete this. Let's want to store a series of number. Let's say marks. Let's say math marks of class 6, right? So let's say in the 6 standards there are let's say 50 students. There are 50 students, and you want to keep their each and every student's math marks. Okay, each and every student math marks. In that case, you'll be using vector. You'll be using vector. So vector is nothing but a series of scalars, right? A series of scalars. So you'll have 50. You can actually store like this. You'll have 50, let's say, and the index starts at 1, 1, 2, first, second, third value, fourth value, fifth value. Like this, you'll have 50 values. You can create a vector, and you can actually store all the numbers. Let's say math mark is somebody scored 91, somebody scores 35. Sorry for that, 35. Somebody scored like say 66, 71, 87. Like that, you can store all the numbers. Let's say somebody 50 score. Let's say score 100. So you can store all these numbers. Okay, so that is how you can use a vector. Okay, so we will be talking in detail about vector in today's class. And sorry for because we have spent some time during discussing a lot of other stuffs. So I'll be stretching it by 20 more minutes. Okay, so we'll be finishing by 10:50 today. Okay, instead of 10:30, 10:50. Is that fine for both of you? If I stretch it to 10:50 today, please tell me. Fine, fine. Okay, cool. So vector, right? So vector is instead of a single value, if you want to represent, if you want to store a series of values, so you can use a vector. It's almost like a one dimensional array, right? If you have remember one dimensional array, just store some numbers. So you can do that. In matrix, matrix is two dimensional. Okay, matrix is two dimensional. Let's say, for example, let's say distance between city. Let me give you a very nice example. Distance between cities. Let's say, okay. Let's say I have give me three states, all from Bangalore. Pranav, what are the states you belongs to? What are the cities you belongs to? Bangalore, Bangalore. Let's say Hyderabad. Let's say Pune. Here also I write Bangalore, Hyderabad, and Pune. And yes, currently in Bangalore. So okay, fine. So instead of distance, I'm gonna time. I'm gonna taking time to cover. Okay, let's change it to time to cover from one city to other. It happens when you are going from one city to another. Let's say you are going from Bangalore to Mysore, you may reach soon, but while coming back there might be time, right? Generally, let's say there was 10 samples, 10 time testing has been done, and you found that whenever you went from, let's say, let's not talk about Mysore, because we were Hyderabad, Bangalore, and Pune cities are here. Let's talk about this. When I went from Bangalore to Hyderabad, 10 times I did the test, and on average I got, like, let's say, 11.2 hours I got. Okay, 11.2 hours. When I went to Bangalore and Pune, for 10 times I got an average of let's say 12.3 hours. So like this we're gonna feel, right? And I know that it's all zero. Okay, don't worry, in matrix it's not meant to be zero in the diagonal, because, but for this special case, Bangalore to Bangalore, Hyderabad to Hyderabad, Pune to Pune is always zero, right? And Hyderabad to, let's say, Pune takes me around 10.7 hours, let's say, right? But here, Hyderabad to Bangalore, right? Earlier it was Bangalore to Hyderabad. It is Hyderabad to Bangalore. There might be slight difference because of the 10 tests I've done, and let's say it is 11.5. Like this, I'm just putting some number, 10.1, and Pune, let's say 12.1. Okay, let's say these are all the hours taken by me. So what I'm doing is I am so to represent all this total information, I need a matrix. This is called a matrix. It's a two-dimensional vector. Matrix is nothing but a two dimension. It has two dimension. It has number of rows, number of columns. Not necessarily 3 by 3 or 4 n by n. Not necessarily n by n. It can be anything. It can be. This is a n by n example I have given. There might be something else. Um, it can be 5 by 3, it can be of any, okay, it can be of any length. So row can be anything, column can be anything, but not one. Okay, it should not be one. If it is one, then it's not a matrix. So it's a two-dimensional vector. Okay, matrix is a two-dimensional vector. So today we'll be discussing about vector and matrix in detail. Okay, now let me uh, show you how how do I store some value into a vector. Okay, so before I jump to that, let's talk about vector. If you remember, what have I done? I have done something like I have told you in a sequence number, right? I've told you it's a sequence. This is a column, is a sequence, right? If I write 1 to 5, it will give me 1, 2, 3, 4, 5. Actually, what it does is it actually returns you a vector having 5 numbers, 1, 2, 3, 4, 5. Okay, so that's a very initial, very preliminary example of how to create a vector. So you can actually create vector by giving a sequence. right? So what you have done is, what here it has done is, it has created a sequence of 5 to 10. That means 5, 6, 7, 8, 9, 10 is a vector, and it has assigned to a variable called a. So now a is a vector which contains 5, 6, 7, 8, 9, 10. Let's just look at it. Okay, let me try that for you. Okay, so a, you can write arrow mark or something like that, arrow mark, or you can just write equals to, no problem with that. Okay, and I'm just saying 5 to 10. So 5 to 10 means 5, 6, 7, 8, 9, 10. Total 6 numbers are there. Okay, so I have stored 5, 6, 7, 8, 9, 10 in A. So if you just type A, so it will give you 5, 6, 7, 8, 9, 10. You can also write print. Okay, you can also write print A. Just writing A or print A gives you the same thing in command prompt, but it is always advisable to write print A. And just wait for next class, you'll know why I'm just writing print A, because let me just give you an example, small example here. Let me write the same code here in the source file. Okay, inside a file I'm writing the same thing. A equal to a equal a what is happening? A equal to 5 to 10. Now I print A, it will not gonna work. Let me show you. See, what I've done is I have just click on it, say save source on save. Don't worry about it. I'll tell you all this thing in detail. Say source, whenever I'm gonna save this instruction, right, it will directly run on it. So it has done source. It is running this file, okay, but it is not printing. When I say A, it is not printing a value. It will not print. If it is in, if you are writing this inside a script and you are running the script, running the file basically, it will not print you the value of a. So you have to write print of a. Okay, so if you do that, then I save, I can have those printed. Okay, so in order to print something, you have to exclusively write print function inside the file. But if you're running on the command prompt, you can just write the variable name, it will run. Okay, that is why I told you it's better, it is always better to use print function. Okay, right? So my a here is 5 to 10, right? So how many numbers? Six numbers, right? 5 to 10 is six numbers. So if you want to know how, what is the length of a vector, now a is a vector, right? What is the length of a vector? length, length function is a function. Just pass the vector a, it will tell you what is the length of the vector, right? And second thing is, what is the type of, what is the type of a? Type of a means what kind of number, what kind of value the vector a contains. Okay, what kind of value a contains. So this says integer. Okay, it says it contains integer numbers. Why it is saying integer is because 5 to 10, right, this sequence can only happen on integer numbers. Okay, earlier I was telling you that whenever you store something, let's say I store something as x equal to 5, right? Now I can write type of x. Now x is a scalar, but a is a vector. But I'm just trying to see what are the kind of numbers this variable can hold. Now when I say type of x, it should return me for integer, right? Because 5 is an integer, but it will actually return you double because it has stored it as a double format. But what happens is whenever you write something like sequence of 1 to 4 or 1 to 6, something 5 to 8, a sequence, right? A sequence can only happen using integers. Okay, sequence is like increments from with a gap of 1, right? So it only works on integers. That is why when you store a equal to 5 to 10 and write type of a, it will tell you it's integer. Okay, so because sequence works on an integer. Now there is something called class of a. Class of a means what is the what kind of class a, I mean what is the data structure of a, like what kind of data structure a is. Okay, so it says for vector, no, for vector it will not return you anything. You will so when you will see that whenever I'll run a matrix, whenever I'll create a matrix, and whenever I create okay, let me just create a matrix for you quickly. Don't worry about this. Let's say M equal to matrix. Don't worry about the instruction now. I'm just creating a matrix. So I just say 1 to 9, 1 to 9. So 1 to 9, and row, number of rows, n row equal to 3, and column equal to 3. So basically I'm from 1 to 9 number, I'm taking 1 to 9 number, and I'm creating a matrix of 3 by 3. Okay, and M is a matrix. If I see M is a matrix, 1 2 3 4 5 6 7 8 9 is a matrix. If I write type of M, right, I'll be getting integer because M can hold integers. But if I write class of M, it will tell me it's a matrix. Okay, because it's saying M is a matrix, and type of M is like what kind of value this matrix can hold. So this value, it can hold integer numbers. But surprisingly, it's a fact that there is some glitch in R. Actually, it should have tell you vector when you are, because A is it's a vector, right? So when you write class of A, you are expected to get a vector, but it is again telling you the same thing as type of A. So type of A is same as class of A in vector. Whereas in anything else, in data frame or anything in array or matrix, whatever data structure you will be learning, everywhere if you write class, you will get the structure type. Okay, only exception is vector. Okay, so just have a note on that. When if you see something alarming, don't worry about this because there is a small glitch in R. Okay, and there will be a lot of glitches. Sometime you may always find, because R is open source tool, it's not a paid tool, right? So that is something we have to live with it because it's coming free. So nothing comes free, right? So there will be some worry which will always come with a free tool. Okay, so now let's go ahead and check what are the next. Right, so I have just, if you see, I have created a vector, and it is from 5 to 10. So I can see the length by using length function. I can get the data type. I can get the what is the type of it by using the class, what kind of value it can hold by using a function called type of, right? So now let's go ahead and look at the next. Okay, this is one way. Another way, let's say you want to represent some numbers. Let's say let's say you want to create a variable x. Let's say you want to create a vector s, and you want to put some number called 5, 9, 10, 11, 12, and 41. Let's say these are the number you want to put. Okay, these are the number you want to put. I'm just giving a separator so that it is easy for you to understand. So how do I do that? Sequence will not work, right? Because sequence then gives me normal number. But this is a very practical case where I might need something like this. So what should I do in this case is, just write x equals to, or you can write x assign. Okay, you'll be assigning a series of number, right? So C is like a vector. Okay, you are actually creating a vector. C is a function which is creating a vector. So 5 space 9 space 10 space 11 space 12 plus space 41. Okay, now you assign this. Hold on a second, guys. Expected numeric constant. Yes. Okay, it will work only if you give comma. Okay, there are some glitch in the ppt as well, don't worry about this. So you have to if you want to give 5 9 10 11 12 41, let's say these are the numbers, you have to place it by comma. Okay, give a separator as comma, it will work. Okay, so now if you print x, it's like 5 9 10 11 12 41. Okay, don't give space, give comma. I'll correct this in this slide, and the slide will be edited and corrected and will be uploaded for you, okay, by tomorrow. Don't worry about it. So you can also give it like this, right? Now See, I'm not right now. I'm not going flow by flow of the slides, but I'm just going by the flow. You should be knowing it. Now, mm, let's say let's say these are all the ages of few student. Let's say these are all the ages of person. Okay. Let's say there are some ages of the person, and you want to give name for each of this. You want to give name for each of this person. Okay, because you know, okay, 5, 9, 10, 11, 12, 41 are the ages of persons, but whether what is the name of each of them, like who belongs to, like which is this 5 belongs to who, which person, 9 belongs to which person, you need to know that, right? So there is also a way to do that. What you need to do is, so I have let's say, let me just say that, let's say this belongs to a person called A, this belongs to a person called B, this belongs to a person called C, this belongs to a person called D, this belongs to, this age belongs to a person called E, this belong 41 belongs to a person called F, just for the simplification, okay? Easy for me to write. So what I'll do is, I'll say, all okay, X is already 5, 9, 10. Okay, the values are there. Only the thing is I need to assign the names of those particular values. So what I'll do is names of X. Right now it is null. Names of X is null because I have assigned no names. So I need to assign names, right? Names of X is equal to, or you can write this symbol also if you want. C of, create another vector of names. Okay, I'll say A, because now names are string, right? Names are string. You have to give it by double quote or single quote. Anything is fine, but use only one. I mean, either use double quote or either use single quote. Okay, so you can use double quote like this. B, sorry, C, D, E, F, right? Done. Now let's print X and see what is the, let's print X and see what is the output coming. When I type X, it says A, like the 5 value is for the name A, 9 is for name B, 10 is for name C, and this. Now you just print names of X, A B C D E F, right? Now uh, let's say you want to know, okay, I know that the length of X is 6. I know there are 6 elements, there are 6 values stored inside the vector X. I wanted to know the third value of X. Let's say I wanted to know, let's say you wanted to know third value of X. What is the third value of X? And index starts at 1, okay? This is first value, this is second value, this is third, fourth, fifth, sixth. There are some languages like C, Java, C Sharp, where index starts from 0, but for our index starts from 1. Please remember that always. Don't forget that index starts at 1. Okay, sorry. Now I want to know the third value of X. So what you need to do is you have to say third value of X is nothing but X. Give the vector name, put square bracket inside this, put 3. It will give you the third value of X. Let me do that for you. X of 3, 10, right? That's the third value, and the name of is C, right? So that's how you'll get. And let's say you want to find the third, fourth, and fifth value. Let's say you want to find the third, fourth, and fifth value. What am I saying? What is the third, fourth, and fifth value? What are the third, fourth, and fifth value? Right? So in that case, because instead of one number, you are asking me to give me three numbers, and I know that third, fourth, and five are consecutive numbers. So let me do it like this. First, what I will do is x inside this third, fourth, fifth, right? Instead of one value, you are asking me multiple values. Give me pass, show me multiple values. In that case, you have to write C. Again, you have to define a vector inside it. And inside that vector, C, when you write C bracket, it's a vector. You are creating a vector. And I'm creating a vector of those third, fourth, and fifth. I'll just pass the index third, comma, four, comma, five. And it will return me C, D, E, right? This is third, this is fourth, and fifth. 9, 10, 11. 9, 10, 11 are nothing but C, D, E. 9, 10, 11. This is one way of doing it. Had it been third, fourth, and sixth, you would write like this, right? 3, 4, 6 inside C, right? So you have to create a vector and say x of 3, 4, 6. So it will give you 3, 4, 6. Now, let's talk about 3, 4, 5. Okay. Can you tell me another way of finding third, fourth, and fifth value of x? After all this, I have told you sequence and everything. Can you just think of a way of finding three, third, fourth, and fifth value of array of vector x without using C function? That C function. Can you unmute and tell me if you have any idea? Just give me a hint.
X 3 is to 6.
Not 3, 4, 5. 3
3
to
4
5.
5. 3 is to 5.
Okay, correct. Yeah. So 3 to 5, right? Sequence. You have to give a sequence. Because it's continuous, you can give a sequence. But if it is not continuous, you can use C function, C of, and C is not capital, C is a small c. Okay? So that you are correct. So it was whom it was? Anand?
Yeah.
Yeah. Oh, great. Okay.
I had a doubt. Like,
Yeah, please ask.
suppose in this is like 1 to 6. If we are having a huge amount of names, and at that time, how we will be, why
I'll
this R will be used?
why this names are used. See, this is just an example I gave you. It may have, I'll show you. Actually, I can load a data. I can load a data, and the data, let's say I have Excel sheet, and I can load that Excel sheet. Inside that Excel sheet, I will have some name column.
Yeah.
I'll have some name rows, and I'll have some value rows, right? So in that case, we can take that, we can convert that into a vector and put all the names as names into the names part, and value into the value part of the vector, right? You can do that. But for you to explain, I just take a small thing. But generally, if you will not push values or five value in the practical case, right? You will be loading a use file, CSV file or Excel file, or maybe
So you
pulling
mean
some
to
data.
you
Yes,
mean to say that Excel file can be related with this R?
exactly. I'll show you that. In the
Okay.
next class, I'll show you that, but let's try to understand all the basics first. I know all
Yeah.
this question will come. Excel file easily you can load. I'll show you that. Okay.
Okay.
Uh,
Okay.
but that will only see after I cover data frame. There is something called data frame. If you see, I have not, that's not part of this class. Data frame. When I cover data frame, I'll be loading CSV and Excel file and show you to okay, right.
Okay.
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 Okay, so now you have understood vector. Okay, now see Anand and yeah. So see all those. There are lots of slides into this, and me covering everything may not be possible. Okay, but I'm giving you a stage where you can go at home and you can read this and practice. But I'm trying to cover as much as possible. Now let's just scan through all those slides that as present. So we have covered all this. Let's see double, right? Type of double. Okay, I have not shown you a character vector, let's say a string vector. Let's say I have let's say I have let's say I have a vector called I'll be storing something into a vector called s, and what I'll be storing is I'll be storing names. My name is let's say Anand, Let me go by Anand. I say Pranav. Then let's say my name. Let's say Satya. Okay. So I can also store string values into a vector, right? And names, when I say names of values, that's optional. You can store or you may not store. Right now it's a string, you may store or you may not store. It depends. Okay, but you will see what's the names, how the names comes into picture, how useful it is during the couple of few classes now from onwards. So you can store string values. Okay, you can also store logical values. Let's say L is a vector. What I'll do is I can store true, sorry, false, true, true, means store true false like this. Now, but let's say there is this vector called m for mix. What I'm going to do is I'm going to store multiple different types of values. I'll store 10, I'll store 34, I'll say Anand, I'll say true. What I have done is I have just went ahead and stored integers. When double values are integer values, I have stored a string, I have stored a logical value, and I have just created a vector. And let's see what kind of values it contains. So before that, so to know what kind of values this contains, what's the function? Can somebody write? To know what's the values this vector m contains, what should be the function? Let's not print m and c. Tell me what is the function? It's type of, right? Just print type of and say m is saying character. That means it's saying character is nothing but string. So it's saying everything has been stored as string. So if you have a mixed kind of data structure, the values, and one of the value is string, then everything will be converted to string. So let's print m. You see, everything is shown as a double quote, inside double quote. 10 is also a string now. 34 is also a string. And is anyway was a string. True is now a string. Okay. So this is how, if it's a mixed thing and character or a string value is there, it will dominate rest of the variables. Let's say I, instead of Anand, let me just put this much: 10, 34 and true. Let's see what will be happen. So type of, so here I have only two double values and one logical value, right? So type of m, this double. So now it is creating double. So what is happening is 10, 34 and true, right? True and false. True and false. Actually, true and false can be denoted as true, can be denoted as, sorry, 1. The meaning of true, if you convert true as a integer double, it becomes 1. If you convert false, it becomes 0, right? So what it has become is 10, 34 and true, right? True becomes now true can be converted to double, so it has converted it to 1, and everything has become so the type of ma has become double. Let's just print it and see now true has becomes 1. Okay, now couple of more things. Let's say x is true, so x is true. You want to convert this to integer. Okay, let's say you want to convert it to integer. So as integer, you can use a function called adds integer and just pass the, here x is a scalar, x is not a vector. Pass the integer x, pass the scalar x, and it will convert x. See, x was earlier true, now it is converting x as true, integer 1, right? But for example, let's say x is Anand. Okay, let's say X is Anand. So X is a string, right? So type of X is character, or is it? One second. Sorry, I I stored it in capital X, small x. So now type of X is character. Now I will try to convert. Let's see. I'll try to convert this character into integer. This is not possible. Okay, logically this is not possible. Let's see what it will throw. So it's telling like convert this x scalar to integer, and x was character, and it will say not applicable. Okay, so it is not applicable because you cannot convert character to integer. Similarly, you can try functions like as character. You can try as character. Okay, let's say 5. 5 was a number, right? 5 was a double. I have just, instead of storing it into a scalar, I have just passed a value. So 5 was a number, I just converted it into a character or string. So it has just put a double quote. But, right, so this can happen. So like you can also try something as let's say logical, logical, logical. 1, true. As logical 0 is false. Let's try as logical 4, true. Anything more than 1 will be true. Okay, anything other than 0 will be converted to true. If it is a number, you want to make it to logical, anything other than will be true. Let's try something else. -4, let's see what will be the value. True. But as soon as it is 0, it becomes false. Okay, even say 0.8, it becomes true. Anything other than 0 will become true, and 0 will be false. Okay, that's how it will work. So try all this function as dot integer, as dot logical, as dot character. You can actually convert the data types into one from another to from one to another. Okay, please ask questions you have any doubt, or I'll just move ahead. uh,
Doubt will come after practicing.
Sure, yeah, and this if you see, I have covered very less of this, and I'll try to cover again on the next class. But all practice. See, now this is a vector, right? X is a vector. We have already seen how to define a vector and all. So once you define a vector, you can run a function called max. You can run a function called mean. Max will give you the maximum value inside a vector. Let's just see. What was our a, right? It's a, right? A was 5 to 10. So max of a will give you the max number. Mean of a will give you the mean number. So similarly, there are many other functions. Sum of a, it will just sum up all the numbers inside the vector. Mean of a, it will give you the average. MEAN, mean, it will give you the average value, right? And median, it will give you the mid value, right? For 5, 6, 7, 8, 9, 10, it will give you the 7 and 8. So let's see what it gives. It should either give 7 or 8, or it may give you 7.5. Let's see. Mean of a, 7.5, because there are two values, because it has even number of value, there is no mid, real mid, right? 7 and 8. So it has taken the average of 7 and 8, and it has given 7.5 is the, sorry, mean. Okay, let me, anyway, mean is 5 plus 6 plus 7 plus 8 plus 9 plus 10 divided by 6. But let me just check median. I was talking about median, sorry. 7.5 again, because it is now deciding between 7 and 8. Had it been 5 to 9, it would have been 7, because 7 is the mid value, and it's the mid value in the sense two values are smaller than this and two values are larger than this. That's the mid value. But here there are two mid values, so it is just taking an average of those two. Now the range will give you the mean value and max value. Because it is sorted in the sorted order, you see it's very trivial. But mean range can give you the mean value and max value. Variance is statistical function. Okay, don't worry about it. Variance means given a number, it can give you the variance. We'll talk about variance later. Correlation is again is a statistical measure. Okay, we'll talk about that later. But sort of x. Okay, this a is a mistake. Okay, this sort of x. Let's say I have run. If you remember, I have run something like. Okay, let me check what have I run. Guys, will take little more time. Okay, so okay, good. Here it was a mistake. You have to give only comma inside C. X, right? So X is 5, 9, 10, 11, 10, 11, 41. It is also sorted. Oh, it is sorted. Let me just put some other number. 3, 67, 43, 2, 7. Okay. So this is not sorted now. So X is not sorted. Okay. So I have a variable, I have a vector X which is not sorted. You want to sort X, just say sort of X. It will sort the numbers. See, it will sort the number in ascending order, but it will not change X. It is just sorting. If I again type X, it is again the same thing. It is just sort function is not sorting and assigning it to X. Okay. If you want to assign it, let's say I create another vector Y and I assign sort of X. Then you can print Y and it will give you sort value. So let's say you want to sort the vector X. Okay, you want to sort the vector X and keep it inside X. You have to write X equal to sort of X. Okay, so that is one. Rank. Now rank. Let's see what is rank of X. Rank of X, what it will tell you is if you sort. So 5, 9, 10, 11, 12, 41, 3, 67, 42. This is 43, this is 2 and 7. If you sort, what would be the rank of 5? So what is the rank of 5? Look at here. 1, 2, 3. Rank of 5 is 3, right? What is the rank of 9? 1, 2, 3, 4, 5. Fifth is the rank of 9 in the sorted order, right? That is what the rank will give you. So for fifth, the value 5 is the third rank in ascending order. Okay, value 5 is the, sorry, 9 is fifth rank. Similarly, 10 is sixth rank, so on and so forth. 2 is the rank 1 in the ascending order. It should be the first number, so the rank of 2 is 1. So you can get rank like this. Now order is little tricky. Try to understand this. Order of X is, you are running. Okay, now listen to this carefully. You are you will be sorting, right? Basically sort of X is you'll sort. So now in the order it says, let me just print it and show it to you first. What it says is, okay, let me print X. X is 5, 9, 10, and order of, let me print order of X. Okay, what it says is, in this first position, in the first position, which index value should come? If you want to sort X, in the first position, which index value would come? 2 should be coming, right? Because 2 is the lowest number. So, but look at what is the index value of 2? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 2 should come in the first position. So instead of bringing 2, it's giving you the index of 2, index of 2, index of the first number in the original series. That should be there in the sorted series. So if you bring the 10th value of X to the beginning, you can start sorting. Similarly, next is bring the 7th value. That means bring 3, 1, 2, 3, 4, 5, 6, 7. Then bring the first value, that is 5. Then bring the 11th value, that is 7. Bring the second value, that is 9. Bring the third value, that is 10. So if you do follow that order, you will get the sorted thing. To show you that, let me just do this for you. X of, what I'll do is, inside this If I write subscript, I will get, if I write 1 to 11, right? I know there are 11 numbers. If I 1 to 11, I get the same numbers, right? Instead of that, I'm going to write order of x, order x. That means I'm passing this order, and I'll see if it can sort, if this will give me the same as sort result. See, this is sorting my numbers. So that is the meaning of sort, that is the meaning of order. Okay, order gives you like which number should, which rank number should come in the first, which index number should come first, which index number should come second, like that. That's the order. Okay, so this is all but do practice. Okay, take some example, do practice on it. Now there are more to it. Okay, we will 4 minutes. I'll stop. We'll start from the next session again. Okay. Uh, so now this is what will happen is, every time, okay, every time you load an Excel file or CSV file in practical world, every value may not be filled up. Every value may not be filled up. You may come across something called missing value, right? You may come across something called missing value. So how to deal with missing values? That's it. That's the slide talks about. Okay, now what here it has done here is, let me annotate. It is saying, let me just say something like this. Inside, so I'm creating a vector where I'm say 10, 11, comma, NA, comma, NA, just writing like this, NA, let's say 7. So what I'm saying is, and let's say I store it to A, some vector A. What I'm saying is, okay, vector A contains 5 values. Vector A contains 5 values. Out of that, 2 are missing. 2 are missing values. NA stands for missing values. NA is a representation in R, which signifies it's a missing value. Okay, it's missing. Okay, so it says there are missing values, right? So now what will happen is, I have 5 values out of like 10, 11, and 7 are there, but 2 O's are NA. Now, if you calculate mean of A, it will not calculate, because there are 2 NA, right? If you put this 5 numbers, let's say there are 2 missing values, and let's say NaN, not a number or something like that, right? You put in Excel and you try to calculate the average or something, it will give you an error, right? Similarly, if you have NA, it will just not work. Mean of A, you want to calculate the average of A, it will not work. So instead of that, instead of just saying mean of A, there is a parameter inside the function mean, or any function on a vector. Okay, any function on a vector, or more than a scalar, basically vector, matrix, anybody will have a parameter called na.rm. So it's saying not applicable, that means missing dot rm, remove. It's asking, should I remove my missing values? If I say equal to t now, it will say, okay, you remove all the missing numbers. Okay, remove all the missing values. By default, na dot rm equal to false. By default, na dot rm equal to false. To show you that, let's just go there. Let me just see the help function, okay, of mean. So help of mean, I can write like this, or I can directly write like this. Question mean. Okay, this will take me to the mean function. So see, this is arithmetic mean, if you see here, and see the default format is given. Okay, default S3 method. So this is the value. There's something called trim. Don't worry about this trim. You can read it always. It's very simple. But we'll talk about this also. But look at this. The point here is this na.rm. So now, like it's saying missing value remove. Na dot rm means na is for missing value, dot rm is remove, is false. By default it is set to false. Okay, so if you just say mean of a, it will not work in this case. So what you have to say is mean of a comma and na dot rm equal to t, that t means true. Then what it will do is it will discard this two value, and 10 plus 11 plus 7 divided by 3 it will do. Okay, and it will give you the number. Similarly here it has, what it has done is na 11 to 15, like 11 12 13 14 15, then na, right? This is what number are generated and it has done. So I've given you separate example for this. Now you can also check, let's say this is your number, this is your vector, right? This is your vector. A is a vector which has some na value. You can also check at which position na's are there. In that case, you just need to use a function called is na. Is na, and if you pass a to it, a is a vector. Okay, a is the same vector. Nothing. A is not a special character. It's a vector to which I have assigned this, some values, right? So if a is na is a function, right? Is na of a, what it will do is it will scan each and every element and it will say, okay, 10 is 10 is not a missing value, right? So it will say false. So now for a was c of, let me just write it here, 10 11 na, sorry, na na and 7, right? So it will return me, is na will return me false. Okay, I'm just writing f for it. Okay, for short format f, 11 is not false. For na it will return me true values. Okay, and for 7 it will again return me false. So it will give me, it will return me a logical vector saying false false true true false. So it will tell me which of the index values are missing. Okay, that is also a way. And if you, this is giving you logical vector, right? But if you really wanted to know which index values are missing, then you just write a function called which of is na of a. The same function, but just pass it to a function called which it will return you the index where na is equal to false. So basically there is the index where the numbers are missing, right? So basically is na of vector a will return you this vector, right? So false false true true false. What which function does is to look at into this vector, and wherever it has true index, wherever it has true, it will pass that index. Okay, so like it is 1, this is 2, this is 3, this is 4, this is fifth index, right? So this which of na will give me values like 3 and 4. Okay, so that's all. So let's just run it and show it to you once. uh, so a equal to c of 11, let's say 12 na sorry, na 7, right? Mean of a will not work, will just not work. Instead of that, we have to do is mean of a comma rm minus, sorry, na dot rm remove equal to t 2, sorry, t for true. If you set this, what it will do is it will take 11 plus 12 plus 7 is 30 divided by 3, because it has discarded these two numbers. So there are only three numbers left, but 3, this mean. Okay, now you want to see which values, like you want to get a logical vector just saying that which, whether the index are missing or index are not missing values, right? So like is dot na of a, say false false true true false, as I said. You just want to know the index at which the missing, where the values are missing. So you just have to pass it to the which function, the same thing, is dot na of a. Okay, sorry, A, the pass function. So it's 3 and 4. Basically, it is just returning the index of true and false. This true. Okay, 3 and 4. 1, 2, 3, 4, 5. So this true. That's how it will work. So which, just remember, which function will always return you the index? Okay, which only return you the index where the condition satisfies. Where the condition satisfies is NA means whether it is missing number or not. So wherever it is missing number, it will pass that index and show it to you. Okay, so like this, there are many, but I would suggest you, guys, you can go on unmute now. Uh, yeah.
Yeah.
So because it was introduction, right? So there are actually 56 slides. It is not possible to cover in absolutely in 1.5 hour. What I'll do is, can we have 1 hour extra tomorrow? Is it possible for you to give me 1 hour extra tomorrow?
Sure.
Right? So
Yeah.
instead of 3:30 to 4, sorry, it was 3 to 4:30. I will finish it off by 5:30. Can we do that?
Okay. No
Uh,
issues.
is it? Yeah. So Saturday, 3:30. Sorry, 3 to 5:30 instead of 3 to 4:30. So that if I get 1 hour extra, I'll try to finish up. Okay. But do one thing. Okay. Now I need to tell you this thing. So do one thing is try to cover as much as possible. This is all easy. I have already told you lots of stuff which you can use. See, uh, after this 0 to 7, sum of y, you can just, it will just do a summation. Sum of y less than 3. Okay, just try practicing all these things. It's very easy. But as much as you can practice, just practice and come to the class. If it's not also, still I'll start from here, okay? I'll start from this page number 20 or 21. And I'll try to cover this in 1 hour and we'll proceed to the next class, okay? Proceed to the next session. And for you guys, okay, now I'll introduce one more package to you. The package is called Swirl, okay? Which I have not introduced to you in the last class. Swirl. Let's look at that. Swirl. The Swirl is a package. Now, what Swirl will do is, Swirl is a package which can help you in learning. It's interactive. It's an interactive window which will help you learning R. Okay, let me just show you. So first you need to do is install.packages Swirl. Okay, always remember, always start your R Studio in administrative mode. Okay, always start your R Studio in admin mode. It is easy because otherwise when you will be installing packages, right, it cannot install packages to where the R is being installed. It cannot install packages inside program files or somewhere. It will only install packages inside your own user directory. So if it does, nobody else can actually use that. It's up to you if whether you want to. Yes, Pranav, it's tomorrow. It is no. Okay. Oh, okay. Uh, tomorrow is okay. Tomorrow is 9 to 10:30. So can we have it like 8:30 to 11? Is it possible? 8:30 to 11, 1 hour, like 30 minutes before and 30 minutes after. Can you give me that much of time tomorrow? Anand say yes. Pranav, okay? Okay. So I'll just ask um, Avinav, our coordinator, to also let other people know about this. Okay, 8:30 to 11 is tomorrow class because there are many slides which we need to cover. Fine. So you need to start using admin mode. Basically, that's the default rule because it's a personal system. You can always be admin. Start with admin mode. Now, uh, what you need to do is it says install dot packages. Sure. Install dot packages, packages packages. Inside that you have to write shrill. Okay. Now be sure uh, be sure that you are writing the exact name, because the package name are case sensitive. If you write capital S, it will not gonna work. Okay, be sure about that. SWIRL, Swirl. So if you install, it's gonna install Swirl for you, and we'll be beginning in a moment. Just hold on. So it is. Just hold on, because Swirl has a dependency on some other packages. If Swirl needs to be installed after installing some other packages, what it will do is first it will go and install the other packages. After that, it will install Swirl. Okay, that is what exactly it is doing now. It Swirl gonna take some time for everybody. Okay. Actually, the next class we have something called practice. Okay. In the class there will be some test, small test. So what we'll do is we'll try to minimize that test time, and we'll try to cover as much as possible. Okay. So okay. So now the shell is installed. Okay. The shell is installed. Let's see. So now what we'll do is just type shell. Okay. Just type shell. SWIRL shell. Give function name and just say start. One second. Shell could not find function. SW. What is the function name? Shell. Learn shell. One second. Give me a moment. You need to start shell. No? Yeah. So okay, there is a mistake I did. What did I do? I have installed Swirl, but I have not loaded the package. The package is installed, but I have not loaded the package. To load a package, what you need to do is go to this tab, this third tab. If you go anti-clockwise, this third tab. Do you see package here? Click on the package, okay, and just search for Swirl. Do you see Swirl? You just hit the radio button. Just tick here. If you tick here, it will gonna load that package for you. Okay, it is loading. It has loaded Swirl package. Now you can type the Swirl function, and it will take you the Swirl window. But this is way I can. This is the way I can actually load this library, right? But if you just want to do it in command prompt, you can also write library. Same thing, library, and say inside double quote just write Swirl, SWIRL, same thing. Okay, here what it has done is it is also giving the path of that library, but path of the library is not needed because this is a default path. Okay, so either you can write the command mode, you can write library Swirl, so it will load the Swirl package, or you can do it like this. You can go to the package, click on, or just put a tick mark on that package. There is another way to load the package, is called require. You say require Swirl is also same as library Swirl. Okay, both are same. This will also work for you. Okay, now I have installed Swirl, and I have loaded my package that's called Swirl. I can just type SWIRL, give a function, so like Swirl function, right? It's a start. Now it is like the prompt has started. So it's saying What shall I call you? So let's say Satya. Call me Satya. So thank you, Satya. It will try to talk to you. Okay. So just you have just have to go read and like sing Satya. Let's cover a quick housekeeping items. We'll begin our first session. Okay. Ready to continue? I am ready to continue. I say press enter. Okay. Now let's see what it's all telling. So one, two, three, press enter. Like continue, proceed. Let's go going. Okay. Uh, Selection. Let's say continue. Okay. So basically, it's just the beginning, right? It's just the way I just told you the first class or something. It's just trying to tell, but after like one or two steps, two three steps, it will start telling you how to code, how to start writing instructions and all. Okay, whatever I am telling, it will also tell you the same way. So you can also at home you can practice this. Start practicing this from today onwards or tomorrow onwards. Use Shrill to practice yourself. Okay, apart from whatever I am teaching. Okay.
Satya, there is one
Yes.
doubt.
Yeah. Please.
I have installed this R Studio, but my R Studio is not looking like yours.
So
I
can
don't
I?
have this port. This is not like four distribution. Yeah,
Okay. Can you share your screen? We can solve that.
yeah.
Is it Pranav Anand?
Anand.
Okay, Anand. Please share your screen.
Yeah, I have shared my screen. It's like RI 386 3.22,
No,
and
I'm yet to see your screen. I'm yet to see your screen.
you can see now.
No, no, not yet.
Just a minute. I have shared. Oh,
No, Pranav, are you able to see Anand's screen? Yeah, I
can you
can see.
see now?
It's coming, coming, it's coming. Yes, yes. Hey, it is R. This is R. This is the
Yeah.
crude R command prompt. Okay, this is that
Okay.
fourth window where I was just typing. Okay, minimize all your windows. Go to the desktop. Let's go to the desktop screen. Show me the desktop screen.
Can you see?
Yeah, just can you just minimize everything? I just need to see whether you have our screen or not. Just minimize everything. Okay. Okay. Can you search for? Can you go to C drive program files? I just need to check C drives program files. Yeah,
Yeah.
program files. R Studio. Do you have R Studio installed? R
Yeah.
R Studio. Go to the R Studio. Can you uh,
Yeah.
can you bring it to the top? Just bring it to the top. I'm not able to see it. Yeah. Or maximize it. No, maximize the window, please.
Okay.
Okay. Now go to the bin file. Okay. You have what you have missed is during the installation you have missed to tick something called like show the screen in the desktop. Like you have forgot to click that. So here you may see something called R Studio. Just click on something and type. Just press R, or you can search R Studio. Do you see R Studio? Yeah.
Yeah.
Right click on it and send to desktop shortcut. Third option. Minimize it.
Okay. Okay.
Done. Or you can
Yeah.
close this. Close this. Close this for time for the timing. Just close this.
Okay. Closed.
Okay. Yeah. Right click on the. You see the R Studio shortcut
Yeah.
on the top. On the top. On the
Yeah.
top. Yes.
Yeah.
Right
Yeah.
click on it. Right click on it. Run as admin. Always run as admin. Okay.
Okay.
If you have permission, always run as admin. So you can see three windows, right? Now, can you click on there is a file icon plus or go to the file
Yeah.
and say new file, say R script.
Okay.
So that's the
Okay.
first window. Second, third, fourth. Same. Your and my
Okay.
screen look same, right? Right.
Yeah. Okay.
So actually in corporate world, right? In your office, you may not be allowed to use R Studio. So if you start practicing on command prompt a lot, right, it is even more better. I mean, it's better. So the script that you are
Which
showing, the
uh,
first window, that's the crude window, right? The console. You see the console
okay.
here, right? The fourth quadrant.
Yeah.
So that's the one you are showing to me. So
Okay.
always try to do everything here. Okay. Don't try to use shortcuts in RStudio. If RStudio is there, it's well and good. But if RStudio is not there, and you have not practiced R on command prompt, it may give you trouble. Like you may get dependent on RStudio a lot. Okay.
Okay. Okay.
So
Okay.
try to use command prompt as much as possible.
Command prompt means this console one.
Console, yes.
Okay. So we while
like
working
like
in a
like like I told you, right, how to include libraries. You can go to the package for tab and include, or you can type library inside that package name. So both you
okay.
can do, right? So but try the command style, right? Library inside that, or require inside that the package name. Don't do this way. I mean, you can do that, both are same, but thing is, uh, the one makes you perfect is the second one, typing everything in console.
Yeah, yeah. In packages there is something boot class cluster pro
Yeah,
tools
these are these are
libraries.
all the packages. These are all the packages which are default. When you
Okay.
installed R, everything got installed. There are many good packages also, but apart
Uh-huh.
from that, those are extra packages that which we may need. That's what
So
there. But yes,
we will be learning about this thing, or I have to
not
R&D and
everything. No, not
uh-huh.
everything. Yes, when you will be, when you are feel comfortable about R, you can go ahead and explore these packages. Okay,
Okay.
but is on need basis. See, there are more than 5,000 packages in CRAN.
Yeah,
Now,
that is what I'm.
give me an answer. Do you need all to work? No, right? It depends upon in which area you are working. Whether you are a data scientist, or whether you are just a application guy, just using it, or whether you are a medical science guy, whether you are something else. Based on that, which package you need will be decided, right? Not everything.
For that we should know the difference now.
Yes, so difference will be there, right? Here, look at this boot. It gives you a difference. So look at cluster. It's, let's say, cluster analysis. That means I know it's a data mining technique. So if you know the area, if you know data mining, you will be easily able to tell me which are the package you should be using, right? So I know it's not very easy, but it's a open source, right? That is how much you have to actually. There's a little bit of struggle always there in R,
Yeah, I am
but
a beginner. I am a beginner, so I
I,
should know it.
obviously, we'll be telling you all the packages that you would need to start
Okay.
the data analyst, right? This course is
Yeah.
more about data analyst, right?
Yeah. Yeah.
Analytical guy, but more onwards data, less on data mining, right? So we'll
Yeah.
be telling you all the packages. Don't worry about that. But 5,000 packages is not possible to tell, right? Even I don't know more
No,
than
I'm not
200.
talking about the 5 standard. I just wanted to
But
understand
yes,
what library is like.
exactly. Yeah. So I'll
What
I'll
like.
show you that. That is why I have kept it to the later class. I'll show you what, when I pick a library, what does it
Hmm.
mean? How do you go and look at the documentation and understand what the package does and whether you
Yeah.
need it or not? That is what your
Okay.
question, right? Exactly, we'll do that. Okay,
Okay.
in the coming classes, to
Okay.
understand whether you need a package or not. The first thing, right?
Okay.
Yeah,
Yeah.
that is what we'll do. So don't worry
Yeah.
about that. It's like
See,
we are little.
if
Yeah.
already 5,000 packages are there, what we are doing right now, are we learning how to make a package, or uh,
How to
are
use
we
package,
how to use
how
our
to use package and get our knowledge implemented. That's it.
yeah, yeah, that's my question
That's
is.
it, right? But as and
Yeah,
when you get expert, you can even you can be also comfortable writing your own code from the scratch. But it's not needed. Basically, it's not needed. We are not
yeah,
doing research here, right? We
yeah,
don't
I
need
am
to
not.
do everything from scratch.
Yeah,
So it's more
by
about
6 months.
using other packages and leverage
I,
their hard work.
I don't believe that by 6 months one can be an expert.